Hello everyone, welcome to day 3. Today we will be going over derivatives of logarithmic functions. So in this section they give us 3 derivatives to memorize. So the derivative of the natural log is going to be 1 over x. The derivative, if you have ln to some function u, is going to be u prime over u, so the derivative of this function over u itself. And then if you have a log of a function, the derivative is going to be u prime over u times ln a, which is a here is the base of the log. We also work with integrals in this section. The integral of 1 over x, it's ln x plus c, and the integral of this form du over u is ln u plus c. So now let's jump into some practice. So if you remember, we're going to find the derivative of ln x cubed, so we're going to use this. And our u here is x cubed, and then u prime is, right, you bring the exponent to the front and subtract 1 from the exponent, so it's 3x squared. So this is going to be equal to, following this, it is u prime over u, which is x cubed. And then you could just cancel out the x's, and then you have 3 over x. So this is your answer for the first one. And then now going to the second problem, we're going to use the same one here. So we have a u here of sine x. So u equals sine x, and the derivative of sine is cosine. And so this is going to be equal to u prime over u, so du, right? Du is u prime, right? So du is cosine x over sine x. And cosine over sine is cotangent. For this next problem, we have a log that is not a base e, so this has base 4. So for these type of logarithms, we use this. Over u times ln a. And so I start off by identifying our u, a, and u prime. So we look at this kind of format. This is the format that this here has. So our u is x squared. And then du is 2x. And then our a, which is the base, is 4. And I just plug in everything in. So then u prime is du is 2x over u is x squared, times ln a, the base 4. And now we could just simplify. This cancels with this, so then we have 2 over x ln 4. Okay, now let's try one integral problem. So if we remember, the integral of du over u, this is what we're going to be using for this problem, is equal to ln u plus c. And the idea is that we want to make this look like this. So the first thing I'm going to do is set the denominator to u. So u equals 3x squared plus 1. And then I'm going to get the derivative of that, which is 6x dx. And I want to, oops, I forgot the dx here, which is part of the problem. So I want to plug in, I want to take out this x dx and plug in a du, right? So that I could have du over u when I plug everything back in. So I'm going to divide by 6. So it's going to be 1 over 6 du equals x dx. So see, now I could plug in the 1/6 du up here. over u, right? 3x squared, I set u to 3x squared plus 1, so I'm putting a u there. And I could move the 1/6 to the front. And now I have it in the format that I want so that I could easily find the integral. So it is going to be ln u, which is 3x squared plus 1 plus c. And then don't forget the 1/6 at the front that we have to multiply by. And that's it. And that's it for today. I'll see you all tomorrow.